Nothing in this room is still. The chair under you is being dragged sideways by a rotating planet faster than sound can move through air. The floor feels fixed because your body is trapped inside the same moving frame as everything around it. That is the first lie. Before we can ask why the universe spins, we have to deal with the more disturbing fact that stillness may not exist at all. Start with the simplest crime scene possible. The room. You are not floating through some abstract model of the cosmos. You are sitting in a structure bolted to the surface of a planet that turns once every 23 hours, 56 minutes, and 4 seconds. Near the equator, that surface is carrying everything on it eastward at roughly 1,674 kilometers per hour. That is faster than the speed of sound at sea level. You feel nothing. No pressure against the wall. No roaring lateral wind. No continuous warning from the inner ear. Your body accepts the room as still, because every major piece of the system is moving with you. The chair, the air, the floor, the building, the coffee on the table, the phone in your hand, the blood in your veins, all of it is being transported together. That is not comfort. That is concealment. Your nervous system is not built to detect constant motion. It detects change in motion. Slam the brakes in a car and your body knows immediately. Sit inside an aircraft at cruising speed and, once the acceleration stops, the cabin becomes ordinary again. A cup rests on the tray. A passenger stands. The aisle seems stable. Even while the whole machine is crossing the sky at hundreds of kilometers per hour. Earth does the same trick, only better. The technical name is an inertial frame. Though Earth's rotating surface is not a perfect inertial frame, the idea is simple enough. Inside a system moving smoothly with you, local physics can look almost identical to rest. A ball drops, water sits in a glass. Your body does not receive a clean internal signal that the entire surface beneath it is being carried around a planetary axis. Wait, think about that for a second. The reason you are calm is not because you are stationary. It is because the motion is too consistent for your body to treat as danger. The illusion of stillness is not proof that nothing is happening. It is proof that you are inside the machine. The atmosphere is inside it too. If Earth rotated beneath a stationary atmosphere, the result would be catastrophic. The ground would tear through the air. Every day would be a global supersonic storm. Buildings would not stand. Oceans would not rest in basins. The surface would live under permanent violence. That is not what happens. The atmosphere is gravitationally bound to Earth and dragged into co-rotation with it. The oceans are carried with it. The lower layers of air are entrained by friction with the surface, while higher layers respond to pressure gradients, solar heating, and planetary rotation. The result is not a rigid shell, but a moving envelope wrapped around a rotating sphere. The planet does not spin beneath an abandoned sky. It pulls the sky with it. This is why ordinary air does not strike you from the west at more than 1,000 kilometers per hour. You, the ground, the oceans, and the atmosphere share the basic rotation. The entire local environment is implicated. The stillness you feel is a conspiracy of shared motion. But the cover is not perfect. Large weather systems expose the frame. When air moves across the surface of a rotating planet, it does not follow this simple path your intuition expects. In the northern hemisphere, moving air is deflected to the right. In the southern hemisphere, it is deflected to the left. This is the Coriolis effect, and it is not some decorative detail of meteorology. It is planetary rotation made visible in the behavior of fluid motion. A hurricane is not just a storm. It is evidence. Its spiral structure is a physical signature written by air moving across a rotating sphere. The storm does not rotate because air has decided to organize itself into a pleasing shape. It rotates because pressure gradients, heat, moisture, and Earth's spin force the atmosphere into a system where straight-line motion becomes curved relative to the ground. Look at a satellite image of a cyclone, and you are looking at the planet confessing. The cloud bands curve because the surface beneath them is not still. The storm is a rotating witness produced by a rotating crime scene. And this is only the outer shell. The planet itself is rotating because it inherited angular momentum from the cloud of gas and dust that formed the solar system. Earth is not an isolated object that somehow began spinning after it was assembled. It was built inside a rotating disk around the young Sunday. The spin came before the finished planet. Earth condensed out of material that was already carrying motion. That matters, because the rotation of Earth is not a local accident. It belongs to a hierarchy. Earth rotates on its axis. Earth orbits the Sunday. The Sun moves around the center of the Milky Way. The Milky Way moves through the local cosmic environment. The numbers become large very quickly, and the mind starts rejecting them because they do not match experience. Earth orbits the Sun at roughly 30 kilometers per second. The Sun and solar system move around the center of the Milky Way at roughly 230 kilometers per second. The Milky Way itself is moving relative to nearby structures at hundreds of kilometers per second. You do not feel that either. Not because it is unreal, because you are embedded in it. Motion becomes invisible when everything you use as a reference is moving with you. Your brain builds reality from local comparisons. The table is not moving relative to the floor. The floor is not moving relative to your feet. The walls do not stream past your eyes, so the room becomes still. The universe has no obligation to agree. At this point, one explanation might seem enough. We feel still because we share Earth's rotation. Weather systems reveal that rotation at large scale. Planets inherit spin from the systems that formed them. The case appears mechanical. It is not, because rotation does not stop at planets or stars or galaxies. It goes downward into matter itself, into a place where the word rotation starts to fail. Inside every atom in your body, physics carries a deeper form of angular momentum called quantum spin. The name is dangerous because it tempts you into the wrong picture. Quantum spin is not a tiny ball literally rotating in space. Fundamental particles are not little planets. An electron is not a bead turning on an invisible axle. Still, the angular momentum is real. It can be measured. It affects magnetic behavior. It determines how atoms interact with light. It helps decide how matter arranges itself. At the deepest level we can currently describe, spin is not something particles do after they are created. It is part of what those particles are. That sounds like a metaphor. It is not. Take hydrogen, the simplest and most abundant atom in the universe. One proton, one electron. That is the basic structure. Both the proton and the electron carry quantum spin. In hydrogen, the relative orientation of those spins matters. Sometimes the electron and proton sit in one spin arrangement. Sometimes the electron flips into another. When it drops back to the lower energy arrangement, it releases a photon with an extremely specific radio frequency. This is the 21-centimeter hydrogen line. Radio astronomers use it to map hydrogen across the Milky Way and beyond. It is one of the great diagnostic tools of astronomy because hydrogen is everywhere. The signal comes from gas spread across space, from clouds that help build stars, from the raw material of galaxies. A tiny spin transition inside the simplest atom becomes a map of cosmic structure. The accounting is obscene. The same category of angular momentum that hides inside your atoms also appears in the rotation of storms, planets, stellar systems, and galaxies. Not the same mechanism in every case. Not the same physical picture. But the same conserved quantity keeps reappearing, changing form, crossing scales, refusing to vanish. The hydrogen in your body participates in this deeper order. The water in your cells contains hydrogen. Your proteins contain hydrogen. Your DNA contains hydrogen. The matter that feels private and biological is built from particles whose quantum properties are governed by rules older than any planet. There is no clean boundary where rotation begins. That is the problem. You can point to Earth and say it rotates because the early solar system rotated. You can point to the early solar system and say it formed from a collapsing cloud with angular momentum. You can point to galaxies and say they acquired spin from gravitational interactions during structure formation. Each explanation works locally. Each one pushes the origin backward. None of them gives you the first cause. The more carefully you examine the universe, the less rotation looks like a feature added onto matter, and the more it looks like a condition that matter inherits, preserves, and amplifies. A cloud collapses, and its tiny spin becomes a disk. A planet forms, and its rotation survives, impacts, tides, and internal friction. A star spins down slowly, but the angular momentum is transferred outward, not destroyed. A particle carries spin as an intrinsic attribute that cannot be peeled away from its identity. The still object was never the default. The non-rotating object would be the freak. A perfectly non-rotating gas cloud would require an exact cancellation of every relevant motion. A planet with no spin would require a formation history with no leftover angular momentum. A galaxy with no rotation would be a rare configuration in a universe where matter collapses, interacts, and exchanges gravitational torque. Random systems do not naturally arrive at perfect zero. They miss it by a little, and gravity magnifies the miss. This is the first crack in the case. At the local level, rotation is easy to explain. Any small imbalance becomes important. Any initial angular momentum survives, unless something transfers it away. Any collapsing system amplifies what it started with. The machinery is not hard to see once you know where to look. But the universe as a whole appears to do something different. Everywhere you inspect, there is spin. Particles carry spin. Planets rotate. Stars turn. Galaxies wheel around their centers. Clusters contain orbiting galaxies. Black holes can rotate so violently that space-time itself is dragged around them. The inventory is overflowing. Then, add it all together. As far as observations can tell, the total rotation of the universe is consistent with zero. No preferred cosmic axis. No confirmed global turning. No large-scale rotation written across the sky, with the kind of clarity that would overthrow the standard picture. Local spin everywhere, global spin nowhere. That should make you uncomfortable, because a universe full of rotating parts but no total rotation is not what your intuition expects. It means the ledger is balancing in a way that may be statistical or structural, or forced by some deeper principle we do not yet understand. Every entry is active. The final sum is silent. That silence is not reassurance. It is the next body on the floor. If the room around you feels still, it is because you are moving with it. If Earth feels stable, it is because your frame hides the rotation. If matter feels solid, it is because quantum rules are doing work below sensation. And if the universe as a whole appears still, then either all of its spins cancel by vast coincidence, or some deeper accounting system is holding the total at zero. The first law we have to interrogate is the one that makes that accounting so merciless. It has a name, and the name sounds harmless until you follow it to the end. Conservation of angular momentum. A spinning object keeps spinning unless an outside twisting force acts on it. That outside twisting force is called torque. Push on the edge of a wheel and you change its spin. Let it float in isolation with no friction, no drag, no gravitational interference, and the spin does not gradually leak away into nothing. It remains. This is where ordinary intuition starts lying again. In daily life, spinning objects stop. A coin rattles against the table and falls flat. A bicycle wheel slows. A ceiling fan winds down after the power is cut. So the brain learns the wrong lesson. It learns that rotation is temporary. It is not. Those objects stop because angular momentum is transferred out of them. The coin gives motion to the table and air. The wheel loses energy through friction in the bearings. The fan pushes air and heats its own mechanical parts by microscopic amounts. Nothing has been destroyed. The motion has been redistributed into the surrounding world, broken into heat, vibration, turbulence, and other motions too disordered for your eye to track. The books still balance. Remove the losses, and the story changes completely. A rotating body in deep space, isolated enough, can keep its angular momentum for timescales that make human history meaningless. Not because it has a hidden engine, not because something keeps pushing it, because, without torque, physics has no mechanism for deleting the spin. That is the trap. The universe is not full of things trying to stop. It is full of things conserving what they inherited. Once angular momentum exists in a system, every later structure must deal with it. It can be moved. It can be shared. It can be converted between spin and orbit. It can be carried outward while matter falls inward. But it cannot simply be erased because the outcome would look cleaner. Nature does not care about clean outcomes. Start at the bottom again. Fundamental particles carry spin, but quantum spin is not a miniature version of a planet turning. It is angular momentum in a form that does not give you a visual picture your brain can safely use. Electrons have spin 1/2. Protons and neutrons are built from quarks and carry their own half-integer spin behavior. Photons, the particles of light, carry spin 1. The Higgs boson carries spin 0. Those labels are not decorations. They classify what the particles are allowed to be. An electron does not sometimes decide to become a spin 0 particle. A photon does not behave like a spin 1/2 particle. When the environment changes, the spin value is part of the identity. Remove it, and you no longer have the same object. The accounting begins before atoms exist. When particles bind into atoms, their angular momenta combine. Electron spin, nuclear spin, and orbital angular momentum all contribute to the allowed quantum states of the atom. The rules are not flexible. They determine which energy levels can exist, how atoms emit and absorb light, and why different elements leave different fingerprints in spectra. A spectrum is not just color spread out. It is a confession under interrogation. When astronomers examine light from a distant gas cloud, they can identify which atoms and molecules are present because those atoms and molecules absorb or emit at specific frequencies. Some of those frequencies depend on rotational states. Some depend on spin arrangements. Matter across space is announcing its internal angular momentum structure, whether that matter is in a laboratory, a nebula, or the cold gas between stars. Move one scale upward, and the same law changes costume. Atoms become molecules. Molecules can rotate. Their rotations are quantized, meaning they are restricted to allowed states rather than taking any arbitrary value. Radio and microwave astronomy can use those rotational transitions to identify molecules in interstellar clouds. Even cold gas drifting between stars is not a featureless fog. It carries measurable angular momentum rules in the way it interacts with radiation. The evidence keeps climbing. At the scale of planets, angular momentum becomes visible enough for instinct to grasp again. The solar system formed from a collapsing cloud of gas and dust more than 4.5 billion years ago. That cloud was not perfectly motionless. It contained turbulence, uneven density, local flows, and small velocity differences across huge distances. Small is enough. Gravity pulled the cloud inward. As the cloud contracted, its rotation rate increased. The reason is the same one used in the ice skater analogy, though the physics is not a performance trick. When a spinning skater pulls their arms inward, the mass moves closer to the rotation axis, and the rotation speeds up to conserve angular momentum. The collapsing solar cloud did the same thing on a scale large enough to build worlds. That is why the young solar system flattened. Gravity tried to pull matter inward from every direction. Angular momentum blocked a clean spherical collapse. Material could fall more easily along the rotation axis, but material moving around the center could not simply plunge straight inward because it had sideways motion to preserve. So it spread into a rotating disk around the forming sundae. The disk came first. The planets formed inside that disk. Dust grains collided. Pebbles formed. Bodies grew through impacts and accretion. The planets inherited orbital motion from the disk and rotational histories from the collisions and flows that assembled them. Earth's spin is not a switch someone turned on after the planet formed. It is a surviving trace of the construction process. It is the fossil motion of material that was already moving before Earth had a surface, before it had oceans, before it had air, before anything alive could mistake the ground for rest. Mars carries its own version of that inheritance. Jupiter carries a much larger one. Saturn's rings display angular momentum so cleanly that they look almost engineered, but there is no engineering. There is only matter trapped in orbit, sorting itself under gravity, collision, resonance, and conservation. The same logic builds stars. A star forms when part of a molecular cloud collapses under its own gravity. The material heats, compresses, and falls inward. Any angular momentum in that material becomes harder to ignore as the collapse proceeds. Young stars often rotate rapidly. Some shed angular momentum through magnetic fields and stellar winds, allowing them to slow over time. Slow does not mean destroy. The sun turns much more slowly now than many young stars do. Its equator takes roughly 25 days to rotate once. That rotation is not the full original angular momentum of the forming solar system. Much of the angular momentum resides in the planets, especially the giant planets, and some has been transported outward through magnetic and gravitational interactions. The system redistributed the motion. It did not delete the problem. This is why star formation contains its own angular momentum crisis. If all the angular momentum in a collapsing cloud stayed in the material falling toward the center, the forming star would spin too fast and tear itself apart or fail to assemble properly. For a star to form, angular momentum has to be transported away from the inner region. Magnetic fields, jets, winds, turbulence, and disks become part of the machinery that lets gravity keep working. The universe builds stars by getting rid of spin locally without getting rid of it globally. That distinction is fatal. Because the same process appears around black holes, neutron stars, and forming stars as accretion disks, matter falling toward a massive central object almost never falls perfectly straight in. It arrives with some sideways motion. That sideways motion is angular momentum, and once it exists, the gas cannot just drop vertically into the center. It has to orbit. As the gas moves inward, it rotates faster. Friction, turbulence, magnetic fields, and instabilities transfer angular momentum outward through the disk. The inner material can then fall closer to the central object, while outer material carries away the excess rotational burden. The result can be violent. Accretion disks around black holes can heat to extreme temperatures and release enormous amounts of radiation. The engine is not exotic at the foundation. It is bookkeeping. Matter wants to fall. Angular momentum refuses to let it fall simply. So the system builds a disk, heats the gas, transfers spin outward, and feeds the center only by exporting the angular momentum problem to larger radii. The bright disk is not just an object. It is the visible cost of conservation. Galaxies obey the same accounting at still larger scale. The Milky Way is a rotating disk of hundreds of billions of stars, gas clouds, dust, dark matter influence, and gravitational structure. At the sun's distance from the center, one orbit around the galaxy takes roughly 250 million years. Our solar system has made only about 20 such circuits since Earth formed. 20. That is all. The planet feels ancient because rocks remember billions of years. Life feels ancient because evolution unfolded through unimaginable time. But measured against the rotation of the Milky Way, Earth has barely gone around the block. Dinosaurs lived under a solar system in a different part of its galactic path. Every extinction, every ocean shift, every continent collision happened while the sun moved through a rotating structure so large that a single orbit contains whole eras of biology. And that rotation is inherited too. Galaxies did not wake up and decide to spin. Their angular momentum arose from the gravitational growth of structure in the early universe, from uneven density fields, from tidal torques between neighboring proto-galactic regions. Each galaxy's spin is tied to interactions with surrounding matter. One region gains angular momentum in one direction. Another carries a compensating share. Local order, global constraint. The pattern repeats with almost mechanical cruelty. A system forms. It inherits angular momentum. It amplifies that angular momentum during collapse. It redistributes it through torques, disks, magnetic fields, winds, tides, impacts, and orbital exchanges. Then a later observer points at the finished object and asks why it is spinning. The answer is always older than the object. That is the crucial fact. Earth spins because the solar nebula carried angular momentum. The solar nebula carried angular momentum because the interstellar gas out of which it formed had motion. Stars spin because collapsing clouds do not start at perfect zero. Galaxies spin because structure formation exchanges angular momentum through gravity. Particles carry spin because quantum fields allow, and in many cases require, specific angular momentum properties. Every explanation is valid. None is final. The law of conservation of angular momentum tells you how spin survives. It tells you why systems cannot casually lose it. It tells you why collapse magnifies it, why disks appear, why orbiting matter cannot simply fall inward, why rotation persists across time. It is one of the most powerful principles in physics because it works from the smallest tested scales to the largest gravitational systems. Powerful does not mean complete. A conservation law is not an origin story. It says the total amount before an interaction must match the total amount after the interaction. It says the books balance from one page to the next. It does not explain why the first page contains the numbers it contains. That is where the investigation hardens. If every spinning structure inherited its angular momentum from an earlier configuration, and that earlier configuration inherited or exchanged it from something before that, then the chain runs backward toward the beginning of cosmic structure, toward the earliest measurable conditions of the universe. At each step, physics can describe the transfer. At each step, the ledger remains intact. Then the trail hits the first wall. Where did the opening balance come from? Not the spin of Earth, not the rotation of the Milky Way, not the angular momentum of one collapsing cloud or one forming star. The deeper question is why the universe had the rotational content that later systems could inherit at all. Why enough local imbalance existed to make disks, planets, stars, and galaxies, while the total still appears to cancel. The law is merciless about preservation and silent about origin. That silence becomes impossible to ignore when we stop treating galaxies as scenery and start treating them as evidence. Galaxies are not background decoration. They are machines under load, and their rotation is where the accounting starts to look criminal. The Milky Way turns so slowly that no human life can see the motion complete even the smallest meaningful fraction of a full circuit. The Sun, Earth, and everything we have ever built are orbiting the galactic center at roughly 230 kilometers per second. That sounds fast until you compare it with the scale of the track. One full orbit takes somewhere around 225 to 250 million years. One galactic year is almost too large to use, honestly. Earth is about 4.5 billion years old, but measured by the rotation of the Milky Way, it is only about 20 galactic years old. Complex animal life has unfolded across barely a few galactic rotations. The entire human species is a thin mark inside the latest fraction of one circuit. The galaxy is turning, but it turns with the terrible patience of gravity. The dinosaurs did not look up from the same address in the galaxy that we occupy now. The solar system has moved through a rotating disk of stars, gas, dust, and unseen gravitational structure for its entire history. Mass extinctions happened on that moving path. Oceans opened and closed on that moving path. Continents rearranged themselves while the sun was carried around the center of the Milky Way. That motion should have been routine. It was not. When astronomers began to measure how galaxies rotate, they found something that should have broken the visible galaxy apart. The expectation was not complicated. In the solar system, planets farther from the sun orbit more slowly than planets closer in. Mercury moves fast because it is close to most of the mass. Neptune moves slowly because the sun's gravity is weaker out there. A galaxy is not a solar system. Still, if most of the galaxy's mass were concentrated in the bright central region, and if the visible stars, gas, and dust were the main source of gravity, then stars far out near the edge should orbit more slowly than stars closer to the center. The rotation curve should decline. That is what the luminous matter allows. It does not happen. The curve stays flat. Stars in the outer regions of spiral galaxies move at speeds that remain roughly constant far beyond the bright central zones. In some galaxies, the outer material moves so fast that if the visible matter were the full mass of the galaxy, those stars should not be bound. They should be escaping. They should be peeling away into intergalactic space. They are not. They keep orbiting. This is not a small correction. It is not a measurement inconvenience. It is a structural failure in the visible accounting. The stars at the outskirts are moving as if the galaxy contains much more mass than telescopes can see, and as if that mass extends far beyond the luminous disk into a broad halo. The galaxy is rotating under the influence of something invisible. Fritz Zwicky saw an early version of the problem in galaxy clusters in the 1930s. He examined the motions of galaxies inside the Coma cluster and concluded that the visible matter was not enough to hold the cluster together. The galaxies were moving too fast. The cluster needed additional mass, much more than the light suggested. That claim was uncomfortable. It was also early. The decisive rotation evidence came later through the work of Vera Rubin and her collaborators. Rubin measured how stars and gas moved at different distances from the centers of spiral galaxies. The expectation was clear enough to be dangerous. If visible matter dominated the gravitational field, outer orbital speeds should fall. Instead, Rubin found flat rotation curves. Again and again, the outer regions refused to slow down. That sounds like a technical graph problem. It is not. A rotation curve is a map of gravitational truth. It tells you how much mass must be inside a given radius for the observed orbital speed to make sense. When the outer stars move too quickly, the equation does not ask politely for a small revision. It demands extra gravity. So, physics was forced into a corner. Either there is unseen mass surrounding galaxies, or the laws of gravity behave differently on galactic scales than they do in the solar system. Those are not minor options. One says the universe contains a dominant form of matter that does not emit or absorb light. The other says our theory of gravity, successful across so many tests, may not be complete under extremely weak acceleration conditions. Pick your poison. The mainstream answer is dark matter. Dark matter does not mean black dust or ordinary cold gas hidden from optical telescopes. Ordinary matter can be searched for in multiple ways, and it cannot account for the missing gravity. Dark matter means a form of matter that interacts gravitationally, but does not interact with light in the ordinary electromagnetic way. It does not shine. It does not block light like opaque material. It does not reveal itself through color, reflection, or heat in the usual sense. It pulls. That is how we know it is there, if the dark matter interpretation is correct. It leaves gravitational fingerprints in galaxy rotation, cluster dynamics, gravitational lensing, and the growth of large-scale structure. The visible universe behaves as if embedded in a much larger invisible framework. Galaxies are not merely disks of stars. They appear to sit inside halos of unseen mass. The word halo sounds too soft. Think of it as scaffolding. A spiral galaxy's luminous disk is only the lit component of a larger gravitational system. The stars draw the eye because stars are what telescopes easily see. But the motion says the controlling mass is not confined to the light. The outer stars are not violating gravity. They are responding to gravity we do not directly see. That is the central move. Rotation becomes the detector. A galaxy does not need to tell you what it is made of in words. It only has to rotate. The speeds of its stars become testimony. The outer disk becomes an instrument. The mismatch between visible mass and orbital velocity becomes evidence of a missing component in the universe's inventory. Wait, think about the scale of that accusation. The same phenomenon that makes a hurricane curve inside Earth's atmosphere is now being used at another scale and through different physics to expose invisible mass around galaxies. Rotation is not just motion. It is a diagnostic. It is how matter under gravity betrays what is really shaping it. But dark matter is not a finished solution. That matters. No dark matter particle has been directly confirmed in a laboratory. Many candidates have been proposed. Weakly interacting massive particles, axions, sterile neutrinos, primordial black holes in some models. Decades of direct searches have produced constraints, exclusions, refined detectors, and frustration. But no unambiguous detection of the particle or particles that would make the case physically complete. The gravitational evidence is strong. The microscopic identity remains missing. That gap is not cosmetic. It is the difference between knowing that a crime occurred and knowing who committed it. The galaxy rotation curves demand extra gravity under the standard interpretation. They do not hand us a particle in a jar. They do not reveal mass, interaction, strength, production history, and field behavior. They point to an absence with extraordinary consistency. The absence has weight. There is another route through the problem, and it must be treated carefully. Modified Newtonian dynamics, proposed by Mordechai Milgram in the 1980s, argues that gravity or inertia may behave differently at extremely low accelerations. In that framework, the flat rotation curves of galaxies are not caused by an invisible halo of matter. They are caused by a change in the effective law governing motion under weak gravitational conditions. This is not the mainstream view. It is also not stupid. Modified Newtonian dynamics has had striking success in describing the rotation curves of individual galaxies using the distribution of visible matter. That success is precisely why the idea cannot be dismissed with a wave of the hand. It identifies a real regularity. It says the visible matter and the observed rotation are connected more tightly than a naive dark matter picture might lead you to expect. Then, the trouble begins. The approach struggles with galaxy clusters, cosmology, and the full set of evidence that the dark matter framework addresses more naturally. The cosmic microwave background, structure formation, gravitational lensing in systems like colliding clusters, and the broader architecture of modern cosmology all place severe demands on any alternative gravity theory. A successful replacement has to do much more than flatten rotation curves. It has to survive everything else. So the field remains lopsided. Dark matter is the dominant framework because it explains many different observations under one broad structure, even though its particle identity remains unknown. Modified gravity approaches remain provocative because they expose patterns that may indicate the dark matter story is not yet complete in its details. If you are not uncomfortable yet, you have not been paying attention. The rotation of galaxies is telling us that something fundamental is missing from the visible account. That missing thing may be matter we have not directly detected. It may include subtleties in how gravity behaves across huge scales and weak accelerations. It may be a combination of unseen matter, baryonic feedback, formation history, and dynamics that we still do not model perfectly. What cannot survive is the simple picture. The bright galaxy is not the whole galaxy. The stars you see do not supply enough gravity. The luminous disk is not the full machinery. The visible matter is riding inside a larger gravitational arrangement whose deepest nature remains unresolved. Galaxies are rotating inside a mass distribution we infer more than we see. This creates a sharper version of the angular momentum problem. If galaxies were simple visible disks, their spin would already demand explanation through collapse and tidal torques. But they are not simple visible disks. Their rotation is controlled by halos, structure, and formation histories that involve dark matter, or something doing the same gravitational work. The spin of a galaxy is not just the spin of its stars. It is the spin of a composite gravitational system whose dominant mass may be invisible. That changes the evidence trail. In standard cosmology, dark matter begins clumping before ordinary matter can fully collapse into galaxies. It builds gravitational wells. Ordinary gas falls into those wells, cools, forms stars, and settles into rotating disks. Tidal torques between neighboring density regions help generate angular momentum before collapse completes. The visible spiral galaxy is a late product of an older invisible architecture. The disk is not the first structure. It is the visible residue. This means the angular momentum of a galaxy cannot be understood only by staring at its stars. The history lies in the dark halo, the surrounding cosmic web, the tidal field of nearby structures, the mergers it survived, the gas it accreted, and the feedback from stars and black holes that moved matter around. The final rotation curve is a compressed record of billions of years of gravitational negotiation. No wonder the details are hard. Tidal torque theory explains the broad origin of galactic angular momentum. Neighboring overdense regions in the early universe exert gravitational torques on each other. One region gains spin. Another carries a corresponding change. Angular momentum is exchanged, not created from nothing. Collapse then amplifies and reorganizes that spin as matter falls into galaxies. That outline is powerful. It is not precise enough to close the case. Individual galaxies have messy histories. They merge, they accrete gas, they lose gas, they form bars, they grow bulges, they interact with satellites. Their dark halos are shaped by collisions and near collisions that may never be visible in the final starlight. Some galaxies align their spins with filaments of the cosmic web. Others show patterns that depend on mass, environment, and formation history. The universe does not hand us clean laboratory specimens. It gives us wreckage that still rotates. And inside that wreckage, the same relentless rule operates. Angular momentum moves from one component to another. Gas falls inward, while angular momentum is transported outward. Bars redistribute motion across galactic disks. Mergers can spin systems up, cancel spin, or scramble orientations. Tidal interactions can pull long streams of stars and gas out into space while leaving the surviving galaxy changed. The galaxy keeps the record whether or not we can read every line. This is why rotation is so dangerous as evidence. It survives disguise. It outlives luminous phases. It carries memory from the early universe into present structure. It reveals mass that does not shine. It exposes the weakness of intuition trained on solid wheels and local motion. It forces every explanation to pass through conservation, gravity, and formation history at once. The Milky Way is not just turning. It is preserving a verdict. Its stars orbit in a disk shaped by ancient collapse, ongoing gravitational structure, dark matter influence, gas dynamics, and billions of years of interactions. The Sun's 230 kilometers per second around the galactic center is not simply a speed. It is one number inside a massive accounting system that includes everything we see and much that we do not. And the outer galaxy is the line item that refuses to balance without invisible help. That is the problem galaxies introduce into the larger investigation. Rotation began as something hidden by reference frames, then became something conserved by law, and now becomes something accusatory. It points beyond the light. It says the visible universe is not enough to explain the motions of the visible universe. The next crack is even cleaner. Because if rotation exposes invisible mass at the scale of galaxies, it also dictates the shape of almost everything gravity builds. Before there is a planet, before there is a star, before there is a spiral disk bright enough to photograph, there is a collapsing cloud with one unforgivable defect. It is not perfectly still. That is enough to ruin the sphere. A collapsing gas cloud does not need much rotation to change its fate. It only needs a tiny mismatch in motion across a large enough region. One side drifts a little differently from the other. One pocket of gas carries a small sideways velocity. One weak turbulence pattern survives long enough for gravity to take over. Gravity notices everything. At first, the cloud looks harmless. It may stretch across light years. It may be cold, thin, and almost empty by the standards of the air you breathe. Hydrogen and helium drift through it, mixed with traces of heavier elements left behind by older stars. Nothing about that cloud looks like a future system of planets. Then the balance fails. Maybe a nearby supernova shock compresses one edge. Maybe two clouds interact. Maybe the cloud's own gravity finally wins against pressure and internal motion. A denser region begins pulling matter inward. The collapse starts slowly, then becomes harder to stop because more mass gathers in one place. And more mass means stronger gravity. Your intuition expects a sphere. That is the clean answer. Gravity pulls toward the center. It pulls from every direction. A collapsing cloud should fall inward and make a compact, central object. If gravity were the only serious actor in the room, that intuition would be close enough. It is not the only actor. Angular momentum is already there, even if it is weak. The cloud may rotate so slowly that no observer would call it important at the beginning. Across a region measured in light years, the motion can be almost absurdly gentle. But conservation does not care whether the initial spin is dramatic. It only cares that the spin is not exactly zero. Collapse is an amplifier. As the cloud contracts, material moves closer to the rotation axis. The same angular momentum must now fit inside a smaller radius. The rotation rate increases. The effect can be enormous because the cloud has shrunk from a diffuse interstellar structure into a dense forming system. What looked like a minor imperfection becomes the rule that controls the final architecture. This is the same physics behind the spinning skater. But stripped of performance and put under gravitational pressure. Pull the mass inward and the rotation accelerates. Push mass outward and it can carry angular momentum away. There is no moral preference in the law. There is only conservation. The sphere is dead. Material falling along the rotation axis can continue inward more directly. Material with sideways motion cannot simply drop into the center because doing so would require it to discard angular momentum without a place to put it. So the gas begins to orbit. Collisions, pressure, and radiation help flatten the cloud. The chaotic three-dimensional collapse becomes a rotating disk. A disk is not decorative. It is a mathematical consequence. The forming star grows in the center, while the remaining material settles into a flattened protoplanetary disk. Inside that disk, grains collide. Dust becomes pebbles. Pebbles become larger bodies. Larger bodies collide, merge, fragment, and merge again. A planetary system begins as a rotational compromise. The planets are not arranged in a disk because space prefers tidy layouts. They are arranged that way because angular momentum forced the collapsing material into a plane. The flatness is not an aesthetic feature. It is the scar left by conservation during collapse. This is why the solar system has the shape it has. Most planets orbit the Sun in roughly the same plane and roughly the same direction because they formed from the same rotating disk. Their orbits preserve the memory of that disk. Their spins preserve more complicated histories of accretion, impact, internal evolution, and tidal interaction. The system is orderly only because the violence was processed through rules. Earth is one result. Its rotation is not a late accident. It is the outcome of material colliding, merging, and settling inside a disk already carrying angular momentum. The early Earth was struck repeatedly by smaller bodies. One giant impact is thought to be tied to the formation of the Moon. Those collisions changed Earth's rotation, but they did not write the concept of rotation into existence. They edited a document that already existed. That distinction matters. Saturn's rings make the same point with almost brutal clarity. They are thin, bright, and flat because ring particles orbit Saturn while colliding and exchanging energy. Vertical motions get damped. Orbital motion remains. The rings settle into a plane around the planet, a visible arrangement governed by gravity, collision, and angular momentum. They look delicate. They are an accounting system made visible. Accretion disks around black holes take the same logic into more violent territory. Gas approaches a black hole with angular momentum. It cannot fall straight in unless that angular momentum is transferred away. So it forms a disk, heats up, radiates, and slowly migrates inward as angular momentum moves outward through turbulence and magnetic effects. The black hole does not simply swallow the problem. The disk solves it by redistribution. Inner gas loses enough angular momentum to move closer to the center. Outer gas gains angular momentum and shifts outward or changes orbit. The price can be light, heat, jets, and radiation strong enough to outshine entire galaxies when the feeding system is extreme. The shape is the confession. Whenever you see a disk in the universe, you are looking at matter that could not fall cleanly. A protoplanetary disk, a ring system, an accretion disk, a spiral galaxy. Different scales, different details, same underlying obstruction. Gravity pulls inward. Angular momentum says not directly. That refusal builds structure. A universe without angular momentum would collapse differently. Gas clouds could fall more cleanly into compact central objects. Planet-forming disks would not appear in the same way. Accretion would be less elaborate. Rings would not persist as flattened orbital systems. Much of the recognizable architecture of the cosmos would be missing or radically altered. But a universe with any tiny rotational imbalance becomes a factory for disks. This is where zero becomes suspicious. Perfectly zero angular momentum is not easy to obtain in real astrophysical systems. It requires exact cancellation among all the motions in the material. Not almost exact, exact. Every sideways drift, every turbulent velocity, every gravitational tug from neighboring matter has to cancel in just the right way. The universe is not that clean. Clouds are disturbed. Stars explode nearby. Galactic tides stretch matter. Neighboring clouds pull on each other. Turbulence stirs gas across enormous volumes. Density variations grow. Nothing about the real universe suggests a habit of producing perfectly non-rotating collapses. Random motion almost never produces absolute zero when the system is large, messy, and gravitationally connected. A non-rotating star would be the anomaly. A non-rotating planet would be the anomaly. A non-rotating galaxy would be the anomaly. Rotation is not the extra feature. It is what remains after the universe fails to cancel every motion perfectly. Then gravity magnifies the failure until it becomes architecture. That sentence should bother you, because it means structure depends on imperfection. The planets exist in a disk because the cloud was not motionless. The star formed inside a system that had to export angular momentum to keep collapsing. The rings survive because orbital motion cannot simply vanish. The bright accretion disk around a compact object is the visible result of matter being unable to fall without obeying the ledger. The system is always negotiating with spin. Star formation makes the negotiation especially clear. A collapsing cloud has to lose or redistribute angular momentum for material to reach the forming star. If the gas kept too much of its original angular momentum near the center, it would orbit instead of falling inward. The star would be starved by the very motion the cloud inherited. So young stars use machinery. Magnetic fields connect the forming star to the surrounding disk. Jets can launch material outward along the rotation axis. Winds carry away mass and angular momentum. Turbulence and instabilities within the disk move angular momentum outward, so matter can move inward. The system creates channels for the burden. The star is built by exporting spin. That is not a side issue. It is central to the formation of the object. The Sun exists because angular momentum was not allowed to remain locked in the wrong place. The planets carry much of the solar system's angular momentum, while the Sun holds most of the mass. That imbalance is not trivia. It is a fossil of formation physics. Mass and angular momentum did not end up in the same account. This is why the solar system is so revealing. The Sun dominates the mass, but the giant planets dominate much of the orbital angular momentum. Jupiter, especially, carries a major share because it is massive and far from the Sunday. The central object and the orbiting system divided the inheritance unevenly. Again, the books balance. They just do not balance in the way a simple picture expects. Galaxies add another layer of damage. They form inside dark matter halos and along the cosmic web. Gas falls, cools, settles, and forms rotating disks if the conditions allow it. But mergers can disrupt those disks. Feedback can blow gas outward. Fresh gas can arrive later with a different angular momentum direction. Satellite galaxies can tug and distort the system. The finished galaxy is not a clean birth certificate. It is a court file. Some galaxies are elegant spirals. Others are disturbed wreckage. Some rotate in clean disks. Others are elliptical systems where stellar motions are more scrambled. Yet angular momentum is still there, distributed through orbits, halo structure, mergers, and tidal debris. Even when rotation is not displayed as a beautiful disk, the ledger has not been erased. Angular momentum can be made hard to see. It cannot be made irrelevant. At this stage, the first major conclusion is unavoidable. The universe does not need to explain rotation separately for every object. Once matter forms under gravity in a universe with non-zero local angular momentum, rotation, and disk formation become expected outcomes. They are not miracles. They are not decorative patterns. They are what conservation and collapse produce together. That sounds like progress. It is also a trap, because the mechanism explains amplification, not origin. It tells us why a small initial spin becomes a fast rotating disk. It tells us why collapse flattens systems. It tells us why stars, planets, rings, and black hole feeding structures must all deal with angular momentum. But it still assumes that the starting material had some angular momentum to amplify. The first deposit remains missing. Not the deposit into one star-forming cloud. Not the deposit into one galaxy. The deeper issue is the presence of rotational content in the early universe's matter distribution at all. Tidal torques can exchange angular momentum. Collapse can amplify it. Disks can redistribute it. Winds and jets can carry it away from the center. None of that creates the total from nothing. And even if local systems gain spin through exchanges with neighbors, those neighbors receive corresponding changes. One region twists one way, another takes the balancing part of the transaction. The universe can create local rotation while keeping the overall sum constrained. This is not a loophole. It is the entire problem sharpening its teeth. Local motion becomes easy. Global accounting stays cold. The physical universe is therefore full of rotating structures that can be explained by ordinary mechanisms, while the total rotation of the universe still appears to cancel. That means the universe is not simply a spinning machine. It is a machine filled with spin whose full accounting may sum to zero. Every disk is evidence of inherited imbalance. Every local rotation is a preserved clue. Every apparently tidy structure is the aftermath of a collapse that failed to be perfectly still. The next layer is worse, because at least clouds and disks still let you picture matter moving through space. You can imagine gas spiraling inward. You can imagine particles orbiting a planet. You can imagine a galaxy turning. The mind has something to hold. Quantum spin removes even that. At the bottom of matter, angular momentum survives after the picture of rotation has been taken away. That is when the case stops being visual. For ordinary rotation, the mind still has something to grab. A planet turns, a storm curls, a disk rotates around a young star. A galaxy carries its stars around a center so distant that one orbit swallows whole eras of life. The picture is enormous, but the picture still exists. Quantum spin does not give you that mercy. It behaves like angular momentum. It is measured like angular momentum. It is conserved like angular momentum. But if you try to imagine the electron as a tiny ball physically turning in space, the image fails almost immediately. The mathematics does not bend to save it. The first hard evidence arrived in 1922. Otto Stern and Walther Gerlach built an experiment that looked simple enough to be harmless. They sent a beam of silver atoms through a non-uniform magnetic field. A silver atom acts, in some ways, like a tiny magnet because it has a magnetic moment. A magnetic field that changes from place to place can push such atoms differently depending on how their magnetic moments are oriented. The classical prediction was a smear. If those atomic magnets could point in every possible direction, then the beam should spread continuously. Some atoms would be pushed upward strongly, some downward strongly. Many would land in between. The detector should show a broad band, a smooth distribution of outcomes from one extreme to the other. That is not what appeared. The beam split into two. Not 3. Not 5. Not a continuous stain. Two distinct spots appeared on the detector, separated by a gap where the intermediate atoms should have landed. The atoms had not chosen from a smooth range of orientations. They had chosen between two allowed outcomes. The gap was the body. It said something in atomic angular momentum was quantized. Nature was not allowing every value. It was permitting discrete results, as if the atom had walked into the magnetic field carrying a rule the experimenters had not fully understood. The detector did not record a blur of possibilities. It recorded a locked binary split. The deeper embarrassment came later. Stern and Gerlach did not yet have the modern explanation. At the time, the result was understood through the developing language of quantum theory, but the specific source of the twofold split was not clear. Classical orbital angular momentum did not naturally give exactly two outcomes. Orbital angular momentum gives allowed orientations, but not this clean two-result pattern for the relevant electron state. Two outcomes pointed to something else. A few years later, Samuel Goudsmit and George Uhlenbeck proposed the missing property. The electron itself had intrinsic angular momentum. It carried spin. Not orbital motion around the nucleus, not a little planet circling a miniature sun, but an internal quantum property with a value of spin 1/2. Spin 1/2 gives exactly two measurement outcomes: spin up, spin down. Those words are useful and dangerous. They do not mean the electron is literally a little arrow already pointing upward or downward before anyone looks. They mean that when you measure the electron's spin along a chosen axis, the result appears in one of two allowed values, nothing in between. The measurement snaps the system into an outcome the classical world never trained you to expect. The electron does not negotiate. It does not arrive at the detector with a hidden classical orientation that could have taken any angle. Quantum mechanics does not permit that simple story. Before measurement, the spin state can exist in a superposition, a combination of possible outcomes. The experiment does not merely reveal a pre-written classical fact in the old sense. It participates in producing the definite result that appears. That sounds like philosophy until the apparatus draws two marks on a plate. The marks are physical. The split is measurable. The rule survives repetition. This is where rotation becomes something colder than motion. At planetary scale, angular momentum is a thing you can still picture. At quantum scale, Angular momentum becomes a property of a state, constrained by algebra, exposed by measurement, and impossible to reduce to a spinning object in ordinary space. The old picture died when physicists tried to make it mechanical. Suppose the electron really were a small charged sphere spinning on its axis. That sounds natural. A spinning charge would create a magnetic moment. The electron has a magnetic moment. The temptation is obvious. Build a tiny model and let it rotate. Then calculate the required speed. The result is fatal. To generate the measured angular momentum and magnetic behavior, with a classical sphere of the size once imagined for the electron, the surface would have to move faster than light. Not a little faster, absurdly faster. Special relativity does not allow any material surface with mass to reach light speed, much less exceed it by an enormous factor. The model breaks its own neck. This was not a small defect that could be repaired by adjusting the radius or changing the picture slightly. The contradiction told physicists that electron spin could not be explained as ordinary rotation of extended matter. The electron was not a tiny top. The spin was real, but the image was false. That is a rare kind of result. It gives you a quantity and forbids the picture you want to attach to it. Modern physics treats the electron as a point-like particle, at least down to every distance scale we have probed. A point-like object has no surface, no equator, no material body rotating around an axis. There is nothing there that can spin in the classical geometric sense. And yet the electron has spin. Always. It is not acquired by bumping into something. It is not lost by cooling down. It is not a mechanical habit. It is part of the electron's identity, as basic as its mass, charge, and behavior in fields. If you remove the spin one-half property, you are no longer describing an electron. That should feel wrong. It is also the working foundation of modern physics. The next breakthrough came from Paul Dirac in 1928. Dirac was trying to build a quantum equation for the electron that obeyed special relativity. The earlier Schrödinger equation worked powerfully for many atomic problems, but it was not the final relativistic description of the electron. It did not fully respect the structure of spacetime demanded by Einstein's theory. Dirac forced the issue. He wrote an equation that treated quantum mechanics and special relativity as non-negotiable. The result did not merely describe an electron moving fast. It produced spin naturally. The equation required a multi-component wave function, and those components encoded the two spin states of the electron. Dirac did not bolt spin onto the theory as decoration. The mathematics generated it. That is the important part. Electron spin was not inserted to make the experiment fit in some casual way. Once the theory was made consistent with relativity in quantum mechanics, spin appeared as part of the structure. The electron's half-integer spin became a requirement, not a preference. Then the equation did something even more disturbing. It predicted a partner. The mathematics allowed states corresponding to a particle with the same mass as the electron but opposite charge. At first, this looked like a threat to the interpretation. Then the positron was discovered. Antimatter had appeared in the equation before it was confirmed in the laboratory. That should permanently change how you think about spin. An equation built to describe a relativistic quantum electron did not merely explain a known magnetic puzzle. It forced the existence of spin into the theory and opened the door to antimatter. A property that sounds like a tiny rotation turned out to be tied to the deepest compatibility between quantum mechanics and special relativity. The particle is not spinning because it is a little object. The particle has spin because the field that describes it transforms in a specific way under rotations and boosts in spacetime. That is the colder statement. Less visual, more exact. The electron is not carrying a hidden wheel. It is carrying a representation of the symmetry structure of the universe. That phrase sounds abstract because the truth is abstract. But the consequences are not. When you rotate an ordinary object by 360 degrees, it comes back to the same orientation. Turn a cup once, and it looks the way it began. Turn a planet once, and the same face returns. Classical rotation is trained into your body through objects that behave that way. Spin 1/2 particles do something more alien. In the mathematics of their quantum state, a full 360-degree rotation does not return the state to its original form. It takes a 720-degree rotation to restore it completely. This is not because the electron is physically twirling twice like a toy. It is because the mathematical object describing a spin 1/2 particle has a different rotational structure than ordinary objects. Reality allows that. Your intuition does not. The Stern-Gerlach experiment gives the first blunt sign, 2 spots, no smear. The failed spinning sphere gives the second, faster than light, impossible. Dirac gives the third. Spin emerges from the structure of relativistic quantum theory and drags antimatter into view with it. The case is no longer about why things rotate. It is about why reality contains angular momentum in forms that are not motion through space in any familiar sense. This is the hard cut. A galaxy rotates because stars orbit. A planet rotates because material assembled with angular momentum. A hurricane rotates because air moves across a turning sphere. A disk forms because collapsing gas cannot discard its sideways motion. These are difficult systems, but they still belong to the world of extended matter and movement. An electron's spin belongs to another class of fact. It is intrinsic, quantized, bound to identity, measured in discrete outcomes, constrained by symmetry, protected by conservation laws. It participates in angular momentum accounting without being a tiny material rotation. The universe did not merely scale rotation down. It changed what rotation means. That has consequences for everything built from electrons, protons, and neutrons. Atoms are not little solar systems with particles following neat classical tracks. Their structure depends on quantum states, allowed energy levels, spin, and rules that have no clean counterpart in everyday mechanics. The chemical behavior of matter is not painted over classical machinery. It emerges from quantum restrictions. Hydrogen already told us that. The spin relationship between its electron and proton produces the 21-centimeter line, a radio signal that lets astronomers trace neutral hydrogen across enormous distances. That one transition depends on the relative spin alignment of 2 particles inside the simplest atom. The result is a tool for mapping the structure of galaxies. A quantum spin flip becomes an astronomical instrument. That is not poetic. It is operational. Radio telescopes detect the line. Astronomers use it to measure gas distribution and motion. Galactic structure appears in data because hydrogen's internal spin states interact with radiation in a reliable way. The smallest atom becomes a probe of the largest rotating systems. The scales are not separate. They are coupled by law. Spin also determines how particles respond to magnetic fields. It affects atomic spectra. It organizes matter into categories that behave differently under exchange. And that last phrase is where the next part of the investigation begins, because particles with half-integer spin do not simply carry angular momentum. They obey a rule that prevents identical particles from occupying the same quantum state. The name is the Pauli exclusion principle. Do not let the name soften it. This rule is one of the reasons matter has structure at all. It helps build the periodic table. It helps explain chemical identity. It helps keep your hand from passing through the table. It supports white dwarfs against collapse. In even harsher conditions, a related degeneracy pressure helps hold neutron stars against gravity. Spin is no longer a label. It is load-bearing. If the electron had no spin 1/2 identity, if matter did not obey the exclusion rules tied to that spin, the world would not merely look different. Atoms would not assemble into the same shell structures. Chemistry would not produce the diversity we rely on. Solidity would lose its quantum foundation. The floor beneath you is involved. The atoms in your skin are involved. The dead stars in the sky are involved. So the investigation has reached a point that should have been impossible from the opening room. We began with a chair that felt still. We followed Earth's hidden rotation, then conserved angular momentum, then rotating galaxies, then collapsing disks. Now the same case has entered the definition of the electron itself. At the bottom of the visible world, angular momentum survives after motion has lost its image. And once that is true, the next question becomes brutal. What happens to matter if spin is removed from the universe altogether? Remove it, and the universe loses the machinery that makes matter matter. Not gradually. Immediately in principle. The question sounds artificial because no one can physically reach into the universe and turn off quantum spin. But as a test of the structure, it is lethal. If electrons did not have spin 1/2, if protons and neutrons did not belong to the same family of half-integer spin particles, if matter was stripped of the rules attached to that spin, the material world would not simply become thinner or stranger. It would lose its architecture. The key rule is the Pauli exclusion principle. Wolfgang Pauli formulated it in the 1920s, and its statement is brutally simple. No two identical fermions can occupy the same quantum state at the same time. Fermions are particles with half-integer spin. Electrons are fermions. Quarks are fermions. Protons and neutrons, built from quarks, behave as fermions too. That one rule is why atoms do not collapse into sameness. Take electrons around an atomic nucleus. The old picture of electrons as tiny planets orbiting a tiny sun is wrong, but it is still useful to remember what the real theory must explain. Electrons occupy quantum states around the nucleus. These states have energies, shapes, and spin orientations. The lowest energy state cannot hold an unlimited number of electrons. It fills. For electrons, two can occupy the same spatial orbital only if their spins are opposite. After that, the next electron cannot just pile into the identical state. The exclusion principle blocks it. The electron must occupy another available state, usually one associated with a higher energy level and a different distribution around the nucleus. That is the start of the periodic table. Not chemistry as decoration. Chemistry as enforcement. Hydrogen has 1 electron. Helium has 2 electrons filling the first shell. Lithium must place its 3rd electron in the next shell. As nuclei get heavier and more electrons are added, the exclusion principle forces electrons into structured arrangements rather than letting them all sink into the lowest available state. Shells fill. Outer electrons determine chemical behavior. Patterns repeat. That repetition becomes the periodic table. The periodic table is often shown as a chart on a classroom wall, as if it were an inventory made by humans. It is not. It is quantum spin written into chemical order. The reason sodium behaves differently from neon, why carbon can build complex bonds, why oxygen reacts the way it does, why noble gases resist chemical participation, traces back through electron structure to the exclusion principle. And the exclusion principle traces back to spin. Wait, think about that for a second. The difference between carbon chemistry and a dead uniform smear of electrons is not that atoms are tiny hardballs with convenient shelves. The difference is that electrons are half-integer spin particles that are forbidden from occupying identical quantum states. The rule separates them. It stacks them. It forces variety. Without that, all electrons would collapse into the lowest energy condition available around nuclei. The shells that define chemical identity would fail. Elements would stop having the rich pattern of behavior that makes chemistry possible. The world would not lose one chapter of science. It would lose the grammar that lets atoms form meaningful differences. Carbon would not play its role. Water would not have the same place. Proteins, DNA, cell membranes, minerals, air, oceans, bones, rock, and metal all depend on chemistry having structure. Chemistry depends on electron shells. Electron shells depend on the exclusion principle. The exclusion principle depends on the spin statistics behavior of fermions. The chain is not optional. It is load-bearing. The same rule explains something even more immediate. Why does your hand not pass through the table? The naive answer is that solid objects are solid. That answer explains nothing. Atoms are mostly empty space. If the nucleus were enlarged to the size of something you could see, the electron cloud would extend far away compared with it. Matter is not packed like stones in a wall. So what stops interpenetration? Part of the answer involves electromagnetic repulsion between charged particles. But that is not enough to capture the deeper structure. When atoms are pushed close together, their electron states begin to overlap. Electrons from different atoms cannot all be forced into the same quantum states. The exclusion principle creates a resistance to compression because identical fermions refuse to occupy identical states. This is degeneracy pressure. It is not a normal pressure caused by heat in the ordinary sense. It does not come from particles bouncing around because they are warm. It comes from quantum state occupancy. Compress fermions into a smaller volume, and the allowed states fill in a way that forces particles into higher momentum states. The system resists being squeezed. Your hand stops at the table because the quantum structure of matter resists overlap. The surface under your palm is not a true surface in the everyday mechanical sense. It is a boundary created by electromagnetic forces and quantum exclusion. You feel solidity because electrons obey rules that your senses never report directly. The table is not solid because it is full. It is solid because the allowed states are controlled. The ground is a lie. A useful lie, but still a lie. At ordinary scales, the result is stable matter. At extreme scales, the same principle becomes one of the last defenses against gravity. When a star like the Sun exhausts the nuclear fuel in its core, gravity tries to crush what remains. If the star is not massive enough to proceed into a more violent collapse, it can end as a white dwarf, an exposed stellar core no longer supported by ordinary fusion. What holds it up? Electron degeneracy pressure. The electrons are packed into a dense state where the exclusion principle resists further compression. The star is not shining because fusion continues in its core like before. It is a hot remnant, cooling slowly, supported against gravity by a quantum rule tied to electron spin. A dead star stands because electrons refuse to share states. That is not intuition. That is physics enforcing identity. Push the mass too far, and electron degeneracy pressure fails. There is a limit to how massive a white dwarf can be before the support cannot hold. Beyond that threshold, collapse continues. In certain stellar deaths, electrons and protons can be driven together to form neutrons, and the remnant can become a neutron star. Then the same kind of quantum resistance reappears in a harsher form. Neutrons are also fermions. They have half-integer spin. Pack them into a stellar remnant only a few tens of kilometers across, containing more mass than the Sun, and neutron degeneracy pressure becomes one of the supports against collapse. The densities become almost incomprehensible. Matter is crushed past chemistry, past ordinary atoms, into a state where nuclei have lost their familiar boundaries. Still, spin remains in the case file. A neutron star is one of the most extreme objects in the universe, and its existence is tied to the same category of rule that keeps electrons from piling into one atomic state. The world of tables and the world of dead stellar cores are not as separate as they appear. They are linked by fermions, spin, and exclusion. That should disturb the scale of your thinking. The same quantum bookkeeping that shapes the periodic table helps decide whether a stellar corpse becomes a white dwarf, a neutron star, or collapses further. The same deep rule that keeps matter structured in your body also participates in the final state of stars. The cosmos does not use one set of laws for the room and another for the wreckage of suns. It uses the same law until the law reaches its limit. And underneath the Pauli exclusion principle sits a deeper theorem that is famous partly because even the best explainers admitted it resists simple explanation. The spin statistics theorem links the spin of a particle to the statistical rules it must obey. Half-integer spin particles are fermions and obey exclusion. Integer spin particles are bosons and do not obey exclusion in the same way. This division is not a naming convention. It is a structural split in reality. Electrons, quarks, protons, and neutrons belong to the fermion side. Photons, gluons, and the particles that carry the weak nuclear force belong to the boson side. The Higgs boson has spin 0. The photon has spin 1. If the graviton exists as a quantum particle of gravity, it would have spin 2. There is no smooth middle category. Half-integer spin behaves one way. Integer spin behaves another. Matter particles fill states under exclusion. Force-carrying bosons can pile into the same state, which is why laser light can contain enormous numbers of photons occupying the same coherent condition, and why fields can behave collectively in ways fermions cannot. The categories determine behavior. Behavior determines structure. Structure determines whether a universe can contain atoms, radiation, chemistry, stars, and observers. The proof of the spin statistics theorem belongs to relativistic quantum field theory. It depends on the symmetries of space-time, especially the requirement that physics behave consistently under the transformations of special relativity, and on causality. The rule that events separated in a way no signal can cross should not influence each other directly. The mathematics decides which fields must commute and which must anti-commute. Anti-commutation sounds technical because it is, but its consequence is savage. For fermions, the mathematics makes the wave function change sign when identical particles are exchanged. Try to place two identical fermions into the exact same state, and the allowed description collapses to 0. The state is forbidden. That is the exclusion principle appearing from the deeper algebra. The rule is not imposed because atoms need variety. Atoms have variety because the rule is imposed by the structure of quantum fields in space-time. This is the reversal. Spin is not just a property of particles sitting inside the universe. Spin is connected to the way quantum fields fit into space-time symmetries. It tells you how a field transforms when you rotate your coordinate system or change inertial frames. It decides which statistical behavior is allowed. It sorts the universe into matter-building particles and force-carrying particles. The Standard Model is organized by this. Matter fields are built from fermions. Force fields are associated with bosons. The photon mediates electromagnetism and has spin 1. Gluons mediate the strong nuclear force and have spin 1. The weak force carriers have spin 1. The Higgs boson has spin 0 and occupies a different role in giving mass to particles through its field. Spin classifies the actors. It also constrains the script they are allowed to perform. A spin 1 force carrier behaves differently from a spin 0 particle. The number of possible polarization states, the way the particle couples to fields, the angular behavior of interactions, all depend on spin. The structure of particle physics is not a random table of labels. It is built around mass, charge, interaction, and spin as defining data. Again, the same pattern appears. The deeper you go, the less spin looks like a rotating object, and the more it looks like a rule that decides what kinds of objects can exist. The word spin survives because the quantity behaves like angular momentum and belongs to the same conservation structure. But the image of turning matter has already been abandoned. The image was never the law. Now, return to the room. The table holds your hand because electrons are fermions. The atoms in your skin have their chemical identity because electron shells are filled under exclusion. The oxygen in your blood, the carbon in your tissues, the calcium in bone, the silicon in glass, the iron in steel, all depend on the structured behavior of electrons around nuclei. That structure depends on spin. The chair under you is a quantum object pretending to be furniture. The pretense is excellent, but it is still a pretense. Matter feels ordinary because the quantum rules are stable, repeatable, and completely built into everything you touch. You do not notice them because they never fail under normal conditions. The exclusion principle does not announce itself every time your hand meets a surface. The periodic table does not flash its origin each time salt dissolves in water. White dwarfs do not explain themselves when a star dies. The silence is not absence. It is reliability. This is why the question at the center of the investigation has changed. At the beginning, it sounded like we were asking why objects rotate. That was already too narrow. Then galaxies showed that rotation can reveal invisible mass. Collapsing clouds showed that rotation shapes the architecture of systems. Quantum mechanics showed that spin can exist without literal rotation. Now, the exclusion principle shows that spin is part of the reason matter has architecture at all. Remove spin, and the material hierarchy breaks. No familiar atomic shells, no normal chemistry, no ordinary solids, no stable white dwarfs supported by electron degeneracy pressure, no neutron stars supported by the quantum behavior of neutrons in the same way. The world does not merely stop rotating, it loses the rules that let it be a world. The accounting has become unavoidable. Spin is conserved. Spin is quantized. Spin classifies particles. Spin determines statistics. Statistics shapes matter. Matter builds stars, planets, bodies, instruments, and minds capable of noticing that everything around them is moving. The universe is not only full of spin, it uses spin to decide what can exist. That makes the global cancellation even more unnerving. If spin and angular momentum are this fundamental, if local rotation and quantum spin are written into matter from the bottom up, then the apparent absence of any total cosmic rotation is not a trivial background condition. It is a constraint placed across a universe whose parts cannot stop carrying angular momentum. The parts are restless. The sum is silent. And now the silence has to answer for itself. It answers first through cancellation, not explanation. Cancellation. If you add the angular momentum of local systems across the observable universe, the result does not appear to point toward one grand cosmic spin. Galaxies rotate, stars rotate, planets rotate. Black holes can rotate. Particles carry spin. Clusters contain orbiting galaxies. Every scale looks active when inspected locally. Then the largest scale goes quiet. There is no confirmed universal axis of rotation. No observed turning of the cosmos as a whole. No giant preferred direction, written plainly across the sky. The standard picture of cosmology treats the universe, at the largest scales, as homogeneous and isotropic. Homogeneous means broadly the same from place to place. Isotropic means broadly the same in every direction. Those words sound sterile. They are not. They are the wall holding modern cosmology upright. If the universe looked fundamentally different in one direction than another, or if all of space carried a detectable spin around one axis, then the assumptions behind our cleanest large-scale models would be compromised. Expansion, structure formation, cosmic history, and the interpretation of the earliest light would all have to be rechecked. The primary witness is the cosmic microwave background. This radiation is the cooled afterglow of the early hot universe, stretched by expansion into microwave light that reaches us from every direction. It is not perfectly uniform. It contains tiny temperature variations, roughly 1 part in 100,000, and those variations are the seeds that later grew into galaxies and clusters. But those variations do not show a clean, global rotation. That is the important absence. If the universe were rotating significantly, the cosmic microwave background should carry signs of that rotation. A preferred axis, a large-scale twisting pattern. A directional distortion that would say space itself was not behaving the same in all directions. Observations do not show such a signal at any level, that would make global rotation a serious part of the standard model. The limit is severe. Measurements from modern cosmic microwave background surveys constrain any possible universal rotation to something so small that ordinary language breaks around it. If there is any rotation at all, it is restricted to roughly a billionth of a radian over a Hubble time in some analyses. A Hubble time is roughly the age scale of the expanding universe. A billionth of a radian across the age of the universe. That is not slow in the way a galaxy is slow. It is almost a refusal to rotate. The universe could have built galaxies, stars, planets, oceans, chemistry, fossils, observers, telescopes, and theories, and still not turned through any meaningful fraction of a circle as a whole. For practical purposes, the total spin is zero. But practical purposes are not enough. Exact zero and undetectably close to zero are not the same thing. Physics has been broken open before by quantities that looked harmless until measurement improved. A tiny residual rotation, if real and confirmed, would not be an adjustment at the edge of astronomy. It would be a message from the initial conditions of the universe. There have been claims. Some researchers have reported possible asymmetries in the handedness of spiral galaxies across large surveys, suggesting that galaxies rotating one way may slightly outnumber galaxies rotating the other way in certain parts of the sky. If that effect were real, and if it survived every correction for selection effects and classification bias, it could suggest a preferred handedness in cosmic structure. That would be dangerous. Most cosmologists remain skeptical. The claimed effects are small. Galaxy classification can carry subtle biases. Survey geometry matters. Automated image systems can misidentify spiral direction in ways that are difficult to remove completely. Human classification is not immune either. A tiny asymmetry in data processing can masquerade as a cosmic signal if the sample is huge enough. So the responsible position is blunt. No confirmed global rotation has been detected. The question remains scientifically open only at extremely small levels under severe observational constraints, but even the possibility matters because the consequences are not small. A rotating universe is not just a universe with one more number in the model. It is a universe with a preferred direction built into its deepest geometry. And that raises the next problem. Where did all the local spin come from if the whole does not spin? The standard answer begins after inflation. Inflation is the proposed extremely rapid expansion in the earliest fraction of a second. It stretched space by an enormous factor and smoothed away many pre-existing irregularities. If there had been a large global rotation before inflation, the expansion would likely have diluted its observable imprint to a negligible level. That helps with the zero. It does not by itself give you galaxies that spin. For that, cosmology turns to structure formation and tidal torque theory. The early universe, after inflation, was not perfectly uniform. Quantum fluctuations had been stretched into tiny differences in density. Some regions were slightly denser than average. Others were slightly underdense. Gravity began amplifying those differences. Matter did not collapse in isolation. Neighboring overdense regions pulled on each other. Their gravitational fields were uneven. As they formed, stretched, and interacted, they exerted tidal forces. A tidal force is the difference in gravitational pull across an extended object or region. If that pull is misaligned with the region's shape and mass distribution, it can produce torque. Torque changes angular momentum. This is the key move. A forming galaxy can acquire spin because neighboring structures twist it gravitationally while both are still growing. One region gains angular momentum in one direction. Another gains a balancing change. The total angular momentum is not created from nothing. It is exchanged across the forming cosmic web. Local spin appears. Global spin can remain zero. That is the elegance of tidal torque theory. It does not require the universe to rotate as a whole. It lets galaxies acquire angular momentum through gravitational interaction with nearby matter. It turns small, early density variations into spinning structures without violating conservation. The broad outline works. The details still bleed. Real galaxy spins are difficult to predict precisely. The magnitude and orientation of a particular galaxy's angular momentum depend on its environment, merger history, gas accretion, feedback, dark matter halo, and position in the cosmic web. Low-mass galaxies can behave differently from massive ones. Galaxies inside filaments can show alignments that shift with mass and history. The cosmic web is not a clean machine with one simple output. It is a wrecking yard with rules. Tidal torques provide the first organized twist. Later events modify it. Mergers can scramble rotation. Gas falling in later can rebuild disks. Outflows from stars and black holes can move matter and angular momentum. Satellite galaxies can disturb or reshape the system. Dark matter halos can exchange angular momentum with baryonic matter. The galaxy you see today is a survivor, not a pristine record. Still, the principle holds. Local angular momentum can arise from gravitational exchanges inside a universe with no net rotation. The cosmos can fill itself with spinning parts while preserving a vanishing total. Every local spin is paired, directly or statistically, with the rest of the ledger. That sounds like an answer. It is only a partial one. Because the cancellation remains astonishing, the observable universe contains an enormous number of galaxies. Their spins, orbital motions, stellar rotations, planetary rotations, black hole rotations, and particle spins do not line up into a single grand direction. On the largest scales, the vector sum appears consistent with zero. Everywhere, activity. Nowhere, a final turn. This is not the same as saying nothing is rotating. That would be false. It is saying the universe distributes angular momentum so that the total does not declare a cosmic axis. Local systems can be violently rotational, while the aggregate remains statistically silent. The machine spins inside itself. The whole does not. Now the case becomes more severe because general relativity permits solutions in which the universe does rotate. Not our observed universe, as far as we can tell, but possible universes inside Einstein's equations. One of the most famous was found by Kurt Gödel. In 1949, Gödel presented an exact solution to Einstein's field equations. It described a universe filled with rotating matter. The distribution was homogeneous in a technical sense, but the space-time itself had global rotation. This was not a playful mathematical decoration. It produced one of the most disturbing consequences in all of theoretical physics. Closed time-like curves. A closed time-like curve is a path through space-time that returns to its own starting event, not merely the same location later, the same event. A traveler following such a path could, in principle, arrive back in their own past. The curve remains time-like all along, meaning the traveler never locally exceeds the speed of light. The pathology is not a rocket breaking a rule. It is space-time geometry, bending the rule into a loop. That sounds like a calculation error. It is not. Gödel's universe showed that general relativity, by itself, does not automatically forbid global causal loops in every mathematically valid solution. In a rotating universe, the light cones that define possible causal influence can tilt in such a way that a future directed path curves back to its origin. The boundary between before and after becomes infected. Cause can chase its own tail. That is why global rotation is not just an astrophysical parameter. It touches causality. The ordinary world depends on a clean enough distinction between past and future. Memories refer backward. Causes precede effects. A laboratory result is not allowed to prevent the experiment that produced it. Biology, chemistry, history, and consciousness all assume a universe where time does not casually fold back into its own record. Gödel exposed the crack. Our universe does not appear to be Gödel's universe. It expands. It contains a cosmic microwave background consistent with near isotropy. It shows no confirmed global rotation large enough to generate anything like Gödel's causal structure. No one has observed closed time-like curves in the cosmos. The solution is not evidence that time travel exists here. It is worse than evidence. It is permission inside the equations under the wrong conditions. General relativity can allow geometries that offend chronology. Physicists have spent decades asking whether deeper physical principles prevent those geometries from forming in realistic situations. Stephen Hawking proposed the chronology protection conjecture, the idea that the laws of physics may prevent time machines from existing in practice. It remains a conjecture, not a complete theorem that closes every door. So the zero begins to look less accidental. Maybe the universe has no significant global rotation because inflation erased it. Maybe local spin arises through tidal torques while the whole remains statistically balanced. Maybe the cancellation is simply what you get from many exchanges in a universe whose initial net angular momentum was zero. Those are sober possibilities, but another possibility hangs over the case. A universe with significant global rotation might be hostile to clean causality. Not hostile in the way a planet without oxygen is hostile. More fundamental than that. Hostile because the ordering of events could fail at the deepest level. If global rotation allowed closed, time-like curves, then the arrow of time could lose the clean universality that makes ordinary physical history possible. The zero may be protecting the sequence. That statement must be handled carefully. We do not know that the universe's near-zero rotation exists because causality requires it. We do not know that some deeper principle forces the global angular momentum to vanish. We do not know whether the observed cancellation is necessity, inflationary residue, statistical outcome, or an initial condition we simply inherited. But the coincidence has weight. A universe full of local spin yet globally balanced at zero is exactly the kind of universe where complexity can exist without the whole space-time acquiring a dangerous rotational axis. Galaxies can form, stars can spin, planets can turn, particles can carry quantum spin, chemistry can operate, observers can emerge, time can behave, at least on our observable scales, as a one-way structure. If that makes you comfortable, it should not, because the explanation is still incomplete. Tidal torques explain how galaxies acquire local angular momentum. Inflation may help explain why no large global rotation is visible. The cosmic microwave background constrains the remaining possibilities. Gödel shows why the wrong kind of rotation would be catastrophic for causality. None of this tells us why the initial conditions had exactly the balance they had. The universe keeps passing the audit, but the auditor cannot find the first instruction. Every local spin has a story. Earth inherited motion from the solar nebula. The solar nebula inherited motion from interstellar gas. Galaxies acquired angular momentum through tidal torques in growing structure. Particles carry spin because quantum fields transform under space-time symmetries in specific ways. Each account can be followed one level down. Then the chain meets the boundary of explanation. Initial conditions. That phrase is where physics often stores what it cannot yet derive. It means the universe began, or emerged into the phase we can model, with certain values already in place. Density variations, expansion rate, field configurations, matter content, symmetries, perhaps global angular momentum equal to zero, or so close to zero that all current observations cannot separate it from nothing. Initial conditions are not magic. They are also not an answer. They are the opening balance written before the accounting laws begin their visible work. Conservation of angular momentum can carry that balance forward. Noether's theorem can explain why rotational symmetry produces angular momentum conservation. Inflation can dilute certain large-scale features, Structure formation can redistribute motion into galaxies and clusters, but the first line of the ledger remains outside the standard explanation. That is the pressure point. If the universe had started with a large net angular momentum, the sky might remember it. The cosmic microwave background might betray it. Large-scale structure might align around it. In more extreme theoretical possibilities, space-time itself could twist causality into loops. We do not see that. Instead, we see a universe where every part seems free to spin locally, while the total refuses to choose a direction. The balance is too important to ignore. The silence is doing work. And now, the final layer has to be opened. Because the conservation law itself is not arbitrary. Angular momentum is conserved for a reason tied to symmetry. The laws of physics appear to work the same when you rotate your experiment. That rotational symmetry gives angular momentum its protected status. So, the next question is no longer why spin survives. It is why the universe has the symmetries that make survival mandatory, while still refusing to explain the number written on the first page. That reason has a name. Noether's theorem. It is one of the most dangerous ideas in physics because it turns conservation laws into evidence of symmetry. Noether showed that when the laws of physics have a continuous symmetry, a conserved quantity follows. If the laws do not change from one moment to the next, energy is conserved. If they do not change from one place to another, momentum is conserved. If they do not change when you rotate your experiment, angular momentum is conserved. That sounds clean. Too clean. Because it explains why the ledger cannot be altered once the rules are operating. It does not explain why the ledger began with the balance it did. Noether gives the enforcement mechanism. She does not give the opening entry. Rotational symmetry says the laws of physics do not care which direction you face. Turn your laboratory. Rotate your coordinate system. Point the apparatus north, south, upward, or sideways. The underlying laws remain the same. From that indifference comes conservation of angular momentum. The universe does not leak spin because rotation in space is a symmetry of the rules. The accounting is not optional. It is forced by the structure of law. That is why the same conserved quantity follows us from the spin of particles to the orbits of planets, from accretion disks to galaxy formation. Different systems, different mechanisms, same protected quantity. Angular momentum can change location. It can move from an inner disk to an outer disk. It can pass from Earth's rotation into the Moon's orbit through tides. It can be redistributed during a merger. But the total remains constrained. The law is not sentimental. It does not care whether the transfer builds a planet, slows a star, tears gas into a stream, or locks two bodies into a tidal relationship. The law only requires the before and after to balance. Look at Earth and the Moon. Earth's rotation is slowly being drained by tides. The Moon raises tidal bulges in Earth's oceans and solid body. Because Earth rotates faster than the Moon orbits, those bulges are carried slightly ahead of the Earth-Moon line. Their gravity pulls on the Moon, transferring angular momentum from Earth's spin into the Moon's orbit. Earth slows. The Moon recedes. The day lengthens by tiny amounts across long time scales. The Moon moves farther away by a few centimeters per year. Nothing mystical is happening. The angular momentum is not disappearing. It is being moved from one part of the system to another, from the turning of the planet into the orbital motion of its companion. The ledger is merciless, even at home. You can see the same pattern in young stars. The forming star must shed angular momentum to keep growing. Disks, magnetic fields, jets, and winds carry the burden outward. You can see it in accretion around black holes, where gas must transfer angular momentum away before it can fall inward. You can see it in galaxy mergers, where orbital angular momentum becomes internal motion, tidal tails, distorted disks, and altered halos. The universe keeps changing the storage location. It does not cancel the debt locally unless another part of the system takes the other side. This is why the global zero matters so much. It is not that spin fails to exist. It exists everywhere. It is that the total appears to be balanced so completely that no universal rotation announces itself. The local books are filled with motion. The final page sums to silence. Noether's theorem tells us why the books balance. It does not tell us why the first page was written with a zero at the bottom. That is where modern cosmology reaches the edge of its map. The early universe had initial conditions, density fluctuations, expansion rate, matter content, field values, geometry, perhaps a total angular momentum consistent with zero. Physics can evolve those conditions forward. It can calculate how tiny density variations grow into galaxies. It can explain how tidal torques give local structures spin. It can show how inflation might dilute large-scale rotation. But the phrase initial conditions is a locked drawer. It marks the place where the theory begins rather than the place where understanding ends. Some proposals try to remove that drawer entirely. The Hodel-Hawking no-boundary idea imagines a universe that does not begin at a sharp temporal edge in the usual way. Near the origin, time behaves more like a spatial dimension in the mathematics. So, asking what came before the beginning may be like asking what lies north of the North Pole. The boundary is replaced by a smooth geometry. That is elegant. It is not a confirmed solution. It may help soften the problem of a first moment, but it does not hand us a simple physical reason for why the universe's observable rotational accounting looks the way it does. It changes the kind of question we ask. It does not let us pretend the answer is known. Loop quantum gravity takes a different route. It tries to quantize spacetime itself. In that framework, geometry is not infinitely smooth at the deepest level. Area and volume become quantized. The underlying description uses spin networks, mathematical structures whose links carry quantum numbers related to angular momentum. Stop there. The name is not accidental. In this approach, spin is not merely something particles possess inside spacetime. Spin, like quantum information, helps build the geometry of space itself. The smooth space you experience would be an emergent approximation, like the apparent smoothness of water that is actually made from molecules. At the deepest level, the geometry may be assembled from discrete quantum relations. If true, the investigation reverses. We would not ask why objects in space have spin. We would ask whether space itself is built from spin. That is not established physics in the same way the Pauli exclusion principle is established. It is a frontier program, incomplete and contested, but it shows how deep the problem has become. The question of rotation does not stop at planets, or atoms, or galaxies. It reaches into attempts to describe the structure from which space and time emerge. Roger Penrose's twistor theory aims from another angle. It treats certain geometric and quantum relationships as more fundamental than ordinary spacetime points. In twistor thinking, light rays, spin, and spacetime geometry are connected in a different mathematical language. The familiar arena of events may not be the most basic level of description. Again, no final verdict. But the pattern is hard to ignore. Every time physics tries to go deeper, spin refuses to remain a minor property. It appears in particle identity. It appears in quantum statistics. It appears in the classification of forces. It appears in conservation laws. It appears in theories where geometry itself may be quantized or reconstructed. Spin keeps moving from the object into the law, from the law into symmetry, from symmetry into the question of space-time itself. That is the final pressure. The universe is not merely filled with rotating things. The language of angular momentum is embedded in the way we describe what things are, how they transform, how they combine, how they resist, collapse, how they form structure, and how space-time may be organized at levels we have not yet tested completely. And still, the largest total remains consistent with zero. Every local system can have a history. Earth's spin can be traced to formation, impact, tides, and the solar nebula. The moon's recession can be traced to tidal transfer. The sun's rotation can be traced to collapse and magnetic braking. The Milky Way's rotation can be traced to structure formation, dark matter halos, gas accretion, and tidal torque. The electron's spin can be traced to relativistic quantum structure. But the whole asks a different question. Why this universe? Why these initial conditions? Why local angular momentum everywhere, yet no detectable global rotation? If you demand a clean final answer, physics does not currently provide one. That is not failure. It is the actual state of the case. We know a great deal about how angular momentum behaves once it exists. We know it is conserved because rotational symmetry protects it. We know it shapes collapsing matter into disks. We know it exposes hidden mass in galaxies. We know quantum spin is built into particle identity. We know spin statistics helps make chemistry, solidity, white dwarfs, and neutron stars possible. We do not know why the universe's full rotational ledger began with the balance we observe. That missing line is not a small technical gap. It sits beneath everything. The room from the beginning is still around you. The floor still feels stable. The chair still feels at rest. The air does not tear past your face. Nothing in your immediate senses reports that Earth is spinning, that Earth is orbiting, that the solar system is circling the galaxy, that the galaxy is moving through the local universe, that the atoms in your body depend on spin at the level of particle identity. Your senses are not lying in a careless way. They are reporting the local frame. The crime is larger than perception. The room is moving because Earth turns. Earth turns because the solar system formed from rotating material. The solar system formed inside a galaxy whose rotation reveals unseen gravitational structure. Galaxies gain spin through tidal exchanges in the early universe. Matter holds together because spin organizes the behavior of particles. The conservation of angular momentum survives because the laws respect rotational symmetry. Then the whole universe refuses to rotate, at least as far as we can tell. That is the zero, not empty, not passive, not simple. A zero built from cancellation, symmetry, inflationary history, structure formation, and perhaps deeper principles still outside our reach. A zero surrounded by motion. A zero that may be the difference between a universe where time behaves and a universe where causality can fold into loops. You are not sitting in stillness. You are sitting inside balance. Every object around you is part of a rotating hierarchy whose final sum may vanish only because the universe has arranged its motion with extraordinary precision, or inherited that precision from a beginning we cannot yet penetrate. Either way, stillness was never the truth. Stillness was the local disguise worn by a cosmic accounting system that has not made a mistake for 13.8 billion years. And the most unsettling part is not that everything spins. The most unsettling part is that when everything is counted together, the universe seems to know exactly how not to. If this question stays with you, leave your thought below. Not because the universe needs our answer, but because the silence at the center of the ledger is still open.